Welcome to Kim's Bioproduction Academy. Let's understand about the factors that affects enzymes, and the factors that will affect enzymes are temperature, substrate concentration, enzyme concentration, enzyme inhibitors, cofactors, and coenzymes. But in that now, about temperature, we'll not repeat about temperature. From my last slide on photosynthesis, I had said we'll just describe temperature in the same way with enzyme, because photosynthesis was enzyme control process. So let's not do a repetition of the same thing. The only thing that you will change, like when the temperature was low, the rate of photosynthesis was also low. So the language that will change is when the temperature is low, the rate of enzymatic reaction is also low. If the reaction rate ends low enzymatic action. So it's the reaction rate, enzymatic action, enzyme acting. Then you relate with. So let's now start with enzyme concentration. Enzyme concentration. Just as earlier, on the enzyme concentration, so this one is enzyme concentration. This one is the rate of reaction. We are not saying enzyme reaction, but rate of reaction. The graph will just behave this manner. Then it calls to be constant. So this one we use still explain point B. This is a graphical question still. It's an essay question and still can come as a graphical question. So when it comes to the enzyme concentration, still let's explain the way that we explain it for photosynthesis. Explain point A. When you check about this point A, the enzymes concentration is low. What do we mean? And what are we speaking when we are speaking about enzyme concentration? We are speaking about the active sites of the enzymes. We have active sites and the what? So let's say this one is our enzyme. This one is enzyme. This one is the active site of the enzyme. The active site of what? Enzyme. So how do we explain? It's about low enzyme concentration, low rate of reaction. Low enzyme concentration, thus low rate of reaction. You get your first free mark. I said that is a free mark. Does not require any biological knowledge. It's just observation, skill of observation. Then the second mark will be, what's the main reason? Because of low active sites of the enzyme. So it means also there is low, we are saying low enzyme concentration, that's low rate of reaction. When you speak about low enzyme concentration, it's like you have already said low active sites of the enzyme. So the main reason you explain using substrate concentration. So this is because of low substrate concentration. So we're speaking about what? If the enzyme concentration is low, the rate of reaction is low. And the main reason why it's low in that manner, because even at this point, we have low substrate to be acted by those enzymes. And low enzymatic action. And low enzymatic action. Then that is now you go to explain BA and B. We're explaining A and B. You can check you are starting to increase your enzyme concentration. So increase in enzyme concentration leads to increase of rate of reaction. Increase in the rate of reaction rapidly. We are saying increase in what? In the rate of reaction rapidly. What's the main reason why this rate of reaction is increasing rapidly? Because there is increase in the active sites of the enzyme. As you're increasing this one, you're increasing the active sites of the enzyme. And when you're increasing this one, it means more of the substrate are being acted. Because of what? With increase in enzyme concentration, there is more acted or breakdown of the substrate concentration. This leads to increase in what? In substrate concentration being acted by active sites of the enzyme. Hope you get this point. We are saying when you're using this one, you explain using the substrate concentration. When we reverse this one to be substrate concentration, you will be explaining using enzyme concentration. So we are speaking about this because the substrate concentration, because of the low substrate concentration. We can use a realistic example. When we speak about enzyme concentration, it's just the enzymes within our body. Let's speak about in the mouth. In the mouth, we have salivary what? Amylase, right? And this salivary amylase will be breaking down maltose, not starch to maltose, sorry. Starch to. So we are speaking about if you have that low enzyme concentration. What does it mean? It means there will be low rate of reaction because even the substrate that has to be broken down will be low. Then when you increase your active side of the enzyme and you take food, that is a starchy food, that salivary amylase will be breaking down because you're increasing the active sites of those enzymes. And when you increase that active sites of the enzyme, more of those starch will be broken down by this what? Enzyme salivary amylase or the amylase enzyme. And that's why it's increasing, the reaction rate is increasing rapidly. While speaking, what is it be reacting? It's the enzyme reacting with the substrate. That is it. Let's explain at point C. Oh, before that, the first up here, thus increase in enzymatic action. Enzymatic action. And we are speaking about enzymatic action, not reaction. It's the enzyme acting on that what? Substrate. Let's explain from point B and C. We are saying explain from point what? B to C. You can check from B and C, you are further increasing. Further increase in the substrate concentration, in the enzyme concentration, sorry. In the enzyme concentration, the rate of reaction remains constant. You're further increasing enzyme concentration. So it means we are increasing the active sites of the enzymes. And when we increase these active sites of the enzyme, the rate of reaction also increases. What's the main reason? You are increasing the active sites, but it's remaining constant. We can use an example here. You took your breakfast in the morning, that's bread. By around 10, that starch of bread, all will have been acted at that moment. So it means that is why the rate of reaction is remaining constant. The only way that you can make this enzyme to continue working is by adding substrate concentration. So this one is remaining constant because all the substrate have been acted by the enzyme. Because all the substrate have been acted by the active sites of the enzyme. Thus, that is a mark, thus enzymatic action stop. We are saying thus enzymatic action stop. Enzyme will have nothing to act here upon, and that's why just they'll remain to be what? To the action will just stop. Then how can you increase from point B? How to increase reaction rate from point B? Because at B, that is where the constant rate started. So how do you increase from point B? By increasing the substrate concentration. By increasing substrate concentration. So students, you have to understand this one. In your exam, they will not give you necessarily to say a substrate or enzyme concentration. You learners, you should be beyond that. They'll use realistic examples, and maybe they can use here, let's say enzyme pepsin. Enzyme what? Pepsin, and the rate of reaction. So it means your substrate that you'll be dealing with is a protein. If it comes to the substrate, they can speak about a protein. Then it means the rate of reaction, the explanation you'll be using, it depends now on the condition that you're being told was set to. If it was in an acidic condition, it means that just talking of pepsin and renin, and the area that we are speaking about is the stomach. If it's about an alkaline condition, so it means it will be the protein enzyme, but not that one doing in the acidic condition, which is the stomach, but now it's at the duodenum, and this one will be pancreatic. Not pancreatic, sorry, it will be the trypsin enzyme. So hope you have understood about this factor number 1, which is what? Factor of enzyme concentration. Thank you very much.